Hello, students. So we have just finished the chapter 9, that is the properties of solids and liquids. Okay. The chapter 9 is solids and liquids. So now we are going to start chapter 10. So it's about the properties of the solution. Okay. So before starting this chapter, let's review the previous chapter. So last topic we study about the solids. Okay. How many types of the solids? How many types? Watch out. Basically, there are three types. One is and third one is and atomic solids are further classified into three classes. One is network solid, metallic, and group 8 metallic solids. This is a special type. Okay, so students, carbon dioxide, which type of solid? And ice. And which one is a atomic solid? Which one is atomic solid? This one? Okay, yes. And one more. And what are the further classification of this one? Gold is okay, atomic solids, but they have further classification, subclassification. This is called metallic solid, and this is group A. Students, this is a very interesting situation. Could you explain this one? So this is, for example, 100 ml water. There is a 100 ml water. And this is a 500 ml water, okay? So here maybe 100 ml is, for example, here, for example, okay? This is the water. So this is the space vacant. So if you turn the heat button, you start heating, what will happen? If it heat and ultimately it start. If you are heating the water, what will happen? Ultimately it start boiling. Okay. If you stop the heating, if you remove this button, press this button, stop heating, what will happen? Boiling will be stop. Okay. If you heat it, it boil. It boil means its temperature reaches to 100 degrees Celsius. Okay. When you stop heating, this temperature could be 99, 98, and boiling stop. Okay. Okay. But if you put a cool water over its neck, this is a metallic neck lid. If you add cold water, things should. Okay. So when you pull the upper part, it start boiling again. Even we don't heat it. Okay. No, just you are cooling, it start boiling. Do you have any reason? Wait, Shannon. First you are heating, logically it boils. Now you stop the heating, and secondly you are cooling, and it still start boiling. So what is the reason? Yes.
The water vaporized and increase the inner air pressure of the container. And because of the container, because of the change of the air pressure, the water point change as well.
Good. Any other? So if you are cooling this container, it still start boiling. The reason is, maybe I gave you the hint. If you are cooling, what will happen here? If you are cooling the upper part, not this. Its temperature is 99, for example, degrees Celsius. If you are cooling this one, what will be happen here? the water vapors cool down. If they cool down, what will happen? They will condense. Condense means here vapor pressure will be increase or decrease. Just if you cool this vapors, vapor condense, number of vapors decrease because if they condense, they convert it to water. Here, the vapor pressure increase or decrease on cooling. The vapor pressure on cooling here increase or decrease. So what is your answer? Shami and Shami. Vapor pressure go down or go up?
Go down.
Go down because when vapors cool down, they convert into water condense. Then number of vapors decrease, then their collision decrease, their pressure decrease. Okay? If external vapor pressure decrease, what is the effect on boiling point? If external pressure decrease, what is the effect on boiling point? Boiling point decrease or increase? So it means no water start boiling at low temperature 99. That's why water boil if you cool this one. Okay. So this is the reason logically. Okay, students. Now we are going to start the chapter 10. What is the name of this chapter? So here we learn the properties of the solution. So what is the solution? So okay, so these are the objectives. Okay. First one, we will learn what is the composition of the solution. Okay. How the solution is formed, what are the components. Next, what energies are involved during solution formation? Energy means heat. Sometime on solution formation, heat absorbed, sometime evolve. And we also learn how we can increase the solubility, okay? The factor affecting the solubility. Then the vapor pressure of the solution. Previously, we learned the vapor pressure of liquid. Here we will learn the vapor pressure of solution. Solution means you are adding solute. What will be the effect on vapor pressure? Adding the solute. Your first experiment is related to this topic, okay? Then you will learn non-ideal solution, boiling point, and freezing point depression. Do you remember this word? This freezing point depression. You are very familiar with this term because it is related to your lab. The first lab is actually you measure the molecular mass of unknown sample by using this property, depression in freezing point. Okay, first you measure the freezing point of cyclohexane, then you add an unknown solute, and then again you measure its freezing point. Freezing point decrease. Remember? Cheetah, one. So freezing point decrease of the solution. So this principle is used to determine molecular mass of unknown compound. Okay. So here we will learn some properties. And last but not least, the osmotic pressure. So this is the polyhedral properties. So we will deal it in detail. Okay. And last is colloids. Colloids is a different form of the solution. Okay. So okay, let's start. Let's dive in. Number one, what is the first part? Solution composition. So let's learn what is the solution composition, how the solution is formed.
When there is an increase in total entropy. Consider two gases separated by a barrier. If a solution is a homogeneous mixture of two components, the major component is called the solvent, while the minor component is called the solute. Depending on the physical state of the solvent, a solution can be a solid, such as an alloy like brass, gaseous, such as air, and liquid, such as a saline solution. Liquid solutions can also have gases or other liquids mixed in a liquid solvent. If the solvent is water, the solution is called aqueous. A solute dissolved in a solvent other than water, such as iodine in carbon tetrachloride, makes a non-aqueous solution. One solvent cannot dissolve all solutes. Salt will dissolve in water, but oil will separate. Thus, salt is said to be soluble, while oil is insoluble in water. Solubility is the maximum amount of solute that will dissolve in a given amount of solvent at a certain temperature.
Yeah, this is a definition of the solubility, okay? So it is a maximum amount of the solute that dissolve in a given amount of solvent.
Of the intermolecular forces between the solute and solvent molecules, and on the tendency to mix, which is driven by an increase in entropy of the system. Entropy is a thermodynamic measurement of energy dispersal or disorder. A process occurs spontaneously when there is an increase in total entropy. Consider two gases separated by a barrier. If the barrier is removed, the two gases mix spontaneously into a single homogeneous solution. At low pressure and moderate temperature, there are no significant intermolecular forces between their constituent molecules, so the gases behave as ideal gases. Here, forming a solution does not lower the potential energy of the atoms, but their kinetic energy can now be distributed over a larger volume. This dispersal of energy increases the entropy of each of the gases, making solution formation a spontaneous process.
So this is just an introductory video about the solution. So students, here is the definition of the solution. Solution is a homogeneous mixture. Other words, its definition is one phase. One phase. Okay, phase, you understand what is phase, okay? So phase, again, I revise. Phase is defined as the homogeneous part which have of the system. Okay, system means I will discuss in detail, but in chemistry, in thermodynamics, the part of the observation is called system. If you are observing any material inside, for example, this is a bottle. So if you are doing reaction inside, so the inside, that is our part of interest, okay, under observation. That is called system, okay. So system, last time I told system may be open, closed, isolated, okay. So it is a homogeneous part of the system which have all physical and chemical properties same throughout, okay. So for example, water, if I put a water in this bottle, okay, so water is one phase or two phase? One. If I put ice and water in it, good, then it is two phase. Why? Because their chemical properties, chemically the water and ice are same, but their physical properties are different. Water is liquid, that is solid. Water density is higher, ice density is low. It means they are different properties. Okay, so what is this? Right? So this is a solution. Okay, so my question is the taste of this coffee here and here is same or different? If the same, then it is called uniform properties. Then it is called one phase. Okay. But my question is this coffee and this pure water is the same phase or different phase? Its properties are different tastes, its properties different. It is colorless, it is colored. So it means they are two phases. Okay. So students, now you understand the phase. Okay. So solutions are mixture. They are the mixture, but they have the one phase. Okay. Condition is one phase. Okay. Students, milk. Is the milk one phase? Milk contains sodium, iron, protein, and fat. Does the fat soluble in water? It means milk means new life. It contains the fat. Okay, so that is not water soluble. So it means on micro scale, milk is not a solution. It is not one phase. Okay, so if any mixture is one phase, then it is called solution. Okay, how many components of the solution? The components are two: solute and solvent. Solute may be many. This is not never one. Maybe in one solution, many solutes are involved. Okay. If you dissolve sugar, salt in water, how many solutes? Two. Solutes are generally the smaller amount, smaller part. Okay. For example, this is the water. And if you add NaCl, who is the solute? Who is solute? This is the small part, so this is the solute. And this is the main component matrix which dissolve. This is called solvent. Okay. So this is the larger part. Okay. Students, if the solvent is water, what is the name of that solution? If the solvent is water, that solution is called aqueous solution. Okay. If there is no water, then it is called non-aqueous. Okay. Students, this is a solute and this is the solvent. If we mix, what is the name of this one? Solution. Okay. It's combination of two. It is a mixture, not a pure thing. It is a mixture. Solution is always a mixture. Okay. Students, how many types of the solutions? Possibility is your solute may be three types and your solvent may be three types: gas, maybe liquid, or maybe solid. So it means there are 9 combinations. Okay, your solute is gas and solvent is also gas. For example, air. Air is always solution. Air is always homogeneous. Okay. Air is always one phase. It is not possible if we have a container, we have 2 layers of airs. No, they are mixed together. They are one phase, homogeneous. Okay, gas and liquid. So you know the Shoaib, they have a gas in water. So they are called soft drinks, carbonated drinks. So carbon dioxide is a solute dissolved in water. So this is also solution. Gas and solid. Some metals, last chapter we learned in some metals, their atomic sizes in this way, they have some voids, dimples, interstitial spaces. So hydrogen is the smallest molecule. Hydrogen or helium. So they are so small, they can enter in these interspaces. So this metal, if we plug it here, where is the gas and so okay. Plug it. This metal, if we put in the hydrogen, hydrogen is homogeneously mixed inside the spaces. Okay. So actually, palladium is a mixture of hydrogen gas. Palladium is a solvent. Hydrogen is a gas. So then it is hydrogen absorbed by palladium. It is a solution. Okay. Okay. Next, liquid in gas. So you know the clouds. What are the clouds? Actually, water evaporate and it from fine mist, fog or clouds. They are water in gas. So this is here. Still, we have a lot of water vapors. Okay, if you put some ice in it, with the passage of time, you will see some drops on its outer surface. Why? The water vapors condense here. So it means lot of water. So water is a liquid. Water are dissolved in gas. Gas is the air. So it means clouds, mist, fog, they are liquid and gas. Okay. Liquid and liquid. So you dissolve alcohol in water. So this is the liquid and liquid. Liquid and solid. So the solute is liquid and the solid is a solvent. Okay. So mercury and silver. Mercury is a metal. So it is a liquid form. When you mix with the silver, silver is solid form. This is called amalgam. Okay, so mercury is liquid, it dissolves in silver metals, then it forms alloy. Okay, but in this alloy, this is liquid, this is solid. After mixing, the solution is solid. Okay, it doesn't mean the solution, if the solvent is gas, the solution is gas. No, it depends upon the situation. Okay, I will discuss that in the next one. Okay, okay. Solid and liquid. Give one example. Solid in a liquid. What is the example? Is this solid and liquid?
Yeah.
Okay, sugar is liquid, water. So these are the and solid in gas. Actually, this is not the solution. This is not the solution. Okay. Dust particle and smoke particle in the air. Because if the smoke particles in air and smoke particles, they are two phase. They are two phase. That is not the solution. Okay, solid and solid. Any example? Solid and solid. Alloy. Alloy are metal, solids are mixed together. Okay. So that is the mixture. Like the steel. Okay. Students, after making a solution, your resultant solution may be solid because your solution phase depends upon the solvent phase. Okay. Solid. For example, brass. Brass is the solution, but it is a solid solution. Similarly, here are another example. Okay. Liquid. If your solvent is liquid, the resulting solution is also liquid. For example, sugar in water. Sugar is solid, but your solvent is water, liquid. So resultant after mixing, solution is still liquid. And gas. If your solvent is gas, the resulting solution is also gas. Okay, resulting solution is also gas. Okay, so students, answer these quizzes. Which of the following is a solid solution? Which one is a solid solution? 1, 2, 3, 4. Okay, answer me like this. Just. Good. Yes. Good. Okay, third. Majority is third. Good. So students, iodine is solid in carbon. No, sorry. Brass. Okay. After mixing, the resulting solution is solid form. Okay. We didn't discuss this one. Okay, let's just guess. What does solubility depends on? Which factor solubility depends? Intermolecular forces, external force, extent of stirring, and other additives. We didn't discuss this one, but what is your idea? What is the answer? How you can increase the solubility? So just intermolecular forces and entropy decide the solubility, or stirring decide the external force, pressure decide the solubility. What do you think? Possible? Who khai? If you add some additive, solubility increase, is it possible? So it means it's very confusing. I will explain you in the next slides, okay? Okay, again, Let's learn a little bit more about the properties of the solution, okay?
Just sucrose and water. Each drop of lemonade tastes this. Mixtures are substances that are composed of varying amounts of two or more types of molecules or atoms. Sand mixed with iron filings and lemonade are both examples of mixtures.
Student, both are mixture, but which one is solution? Which one is one phase? Here you cannot see the citrus and water compound. They are uniformly mixed. Their composition is uniform, same taste. But here you can see here is only the sand, here is only the iron files. So here you can visually see two different phases. Okay, and composition is not the same. Here maybe more iron, here less iron. Okay, so composition is not fixed. Here pure sand, here more iron, here less iron. So it means it is not a solution. Two phase.
Mixtures can be categorized into two types, heterogeneous and homogeneous.
Yeah. Homogeneous means one phase. Remember. Homogeneous means one phase. And heterogeneous means more than one phase. Okay. More than one phase is not a solution. It is just mixture. This is also mixture, but one phase means solution.
In heterogeneous mixtures, the components are unevenly distributed. Hence, they do not exhibit a uniform composition.
This is molecular level. On molecular level, here is more silicon, less iron. Here, more iron, less silicon. Okay, silica atom. So it means it is not a uniform mixture. Okay, it is not one phase.
In contrast, homogeneous mixtures do have a uniform composition. For example, lemonade is a homogeneous mixture of lemon juice, sucrose, and water. Each drop of lemonade tastes the same due to the uniform distribution of its ingredients. A solution is a homogeneous mixture of two main substances.
This is the definition, but it is not compulsory two component, maybe 3, 4, or multi-component. Yes, solution is a homogeneous mixture of different components.
The solute.
Different components, not two components. If I mix water and water, is it one phase or two phase? If I mix water in water, it is one phase or two phase? Is it solution or not? Because it is not a mixture. Same thing in same is not a mixture, okay? So it should be different component, but it should be homogeneous.
And the solvent. The solvent is present in greater quantity than the solute. For example, in lemonade, water is the solvent, and lemon juice and sucrose are the solutes. In a solution, the solute and solvent can be in any state of matter, solid, liquid, or gas. The state of the solution is the same as the state of the solvent.
Yeah. Students, if I mix gas in liquid, if I mix gas in liquid, what is the state of the solution? Solution is in gaseous form, solid form, or liquid form. If I mix gas in liquid, what is the resulting solution? Solution is in gaseous form, liquid form, or solid form? Liquid. So it means that solvent decide the final form of the solution. Okay. If solvent is liquid, solution is also liquid. If solvent is gas, solution is gas.
The solution itself is a single phase, irrespective of the states of the solvent and solutes. For example, soda is a liquid solution that contains gaseous carbon dioxide and solid sucrose dissolved in water. When the solvent is water, the solution is called aqueous. Lemonade and soda are both examples of aqueous solutions. When forming a solution, the solute and solvent do not chemically react with each other. Instead, the particles are simply redistributed by individual solvent particles surrounding the solute particles and interacting through attractive forces. In the case of an aqueous solution, the dissolving process is called hydration. In general, the interaction of solute with any salt called solvation.
So if any solute dissolve in water, it is called solvation, okay? Solution is aqueous. This process is called solvation. And not the water, sorry, any solvent, okay? Okay, students, no, you have 15 seconds. So you have to be make one solution system. Then I will ask you, you have to be right here. For example, if somebody asks me, oh, write one example of the solution, I will write, oh, sodium chloride in water. So similarly, you have to be write one solution example here. Okay. So remember, just talk with each other and make one solution.
Smaller we call that. So I'm wondering that. Because they should not have any weight. Now, we should do my this so you size as and it's a different orientation. Okay, so it's just like right lights and what the other thing. Not really how who want to be right volunteers? Stone? No. Yes. So. Try to write the one example of this. Water. Please join the call, okay? Ethanol dissolved in sugar in water. Okay, good. In glycerin. Yeah, okay. In glycerin. Students, organic solvent dissolve in organic solvents. Okay. So most of the solutions are aqueous. Okay. Our blood is a solution or not? Our blood. Our blood contains many components, okay? Some are soluble in water, some are not soluble. So I will, at the end of this chapter, you will understand what is exactly blood is, okay? Okay, students, which of the following statement about the components of a solution is true? So component of the solution, they are combined in a fixed ratio. They cannot be separated. They have a uniform composition throughout. They form heterogeneous mixture. What is the answer? So can I mix, if I mix 1 gram in 100 ml water, it is called solution. Can I dissolve 2 gram in 100 ml? 3 gram. Can I change the composition? Okay. Can. So it means it is still called solution. So they combine in a fixed ratio. This is not the condition. You can mix any ratio, okay? They cannot be separated. True? Okay? So it means it is not correct. We can separate it because they are not chemically react with each other.
So we can separate. Okay. Answer is they are from heterogeneous mixture. So this is not the true. Okay, so students, let's come back to the lecture. Here are some more terms. So do you familiar with the saturated and unsaturated and super saturated solutions? Do you know? Do you remember? Okay, saturated. So from this diagram, you can understand. If this is a water, for example, if I add small amount of solute NaCl, so can I dissolve more NaCl in it?
Yes.
Yes. But the amount of solute is very, very high or very, very low. Small amount is very low. So this is called diluted solution. Diluted solution means where solute is very, very small. If I dissolve more and more and more in solute NaCl, this solution become very solid. Okay. Then it is called concentrated solution. But if I dissolve and ultimately if I add more salt, it will settle down. It will not dissolve anymore. It means maximum amount is dissolved. Then it is called saturated solution. And before this is called unsaturated solution. Before this, it is called unsaturated solution. At this stage, when the solute is settled down, maximum dissolve here, extra settled down. This is the indication. It means no solution is saturated. Okay. Student, my next question is, if by any method I dissolve more solute than saturated, then that solution is called super saturated. It means it dissolves more than the saturation. But this solution is highly unstable. Once they are formed, in a few minutes, the excess amount is crystallized and separated. Okay. Then again they become set. So they are not stable. Like super cooled water. Last time you learned super cooled. Similarly, this is a super saturated solution. Okay. So students, before this, these are called concentrated and dilute, but they are called unsaturated. Unsaturated means still you can dissolve more solid. Okay. So before this, unsaturated, saturated, after it, super saturation. Okay. So solution, which solution is the diluted solution? Among this one, I dissolve a color dye in water. Is this is a dilute solution or this one is the most dilute solution? Your opinion. Which side is the diluted solution in this diagram? Which one is diluted? This one. It means less color means solute is less. Okay, solute is increasing constantly. Students, this sentence. Read this sentence. Understand? Students, this is for example water. If I add sugar in it and dissolve it, okay, it dissolves. If I add more and more and more, is there any state where extra amount will not dissolve?
Yes.
Then this solution is called saturated. But students, sometimes this stage never occurs. For example, if this is a water and I am adding ethanol, if I am adding ethanol, there is no situation, no stage reached. If I add 1 ml ethanol, it dissolves. 10 ml dissolved. 50 ml dissolved. Even the amount of water, I add more ethanol than its amount. then still it dissolves. That solution never reached to the saturation. That solution never reached to saturation. And your answer is here. If water is 100 ml and I dissolve ethanol 10 ml, who is solvent, who is solute? Water 100, ethanol 10 ml. Who is the major component? Water. Water is solvent and ethanol is solute. If I dissolve, this is 100 ml, I dissolve 90 ml ethanol. Still ethanol is solute or solvent? Solvent. If I dissolve 110 ml ethanol in 100 ml water, now who is the solvent? Who is the solute? Alcohol is the major component, solvent, because it is more than 100, and water become minor component, solute. Okay, but in this case, we don't say ethanol is water soluble. We say it is miscible. Liquid soluble. We say it is miscible. If liquid dissolve in liquid, we don't say it is soluble. We say it is miscible. Okay. And in this case, we don't use this is solute, this is solvent. Okay. But if you want, you can decide yourself. Major component is solvent, minor component is solute. Okay. You got the answer? You got it? Your answer. Okay. Students, no, you understand? Miscible. Completely miscible means they never reach the saturation point. If you add alcohol in water or water in alcohol, they will never reach the saturation point. They dissolve in all proportion. Okay. So second is immiscible. Immiscible means they don't dissolve at all. If I mix oil and water, does they soluble in each other? No. They are called immiscible liquids. For example, water and benzene, water and carbon disulfide. This is a highly polar, this is a non-polar, not dissolved. So that solution, not solution, this mixture is called immiscible mixture. But students, there is another type that is called partially miscible. I will explain. Okay. Next, we use the term electrolyte and non-electrolyte solution. What does it mean? Electrolyte solution, non-electrolyte solution. If I connect this with the battery, does current flow through it? High to high. Yeah. And this is a sugar, neutral molecule, no charge. If I put, for example, this is some organic solvent, not the water. Okay, for example, if I put an electrode here, does current flow through this solution? No. No. So it means if current flow, it is called electrolyte. If current doesn't flow, it is called non-electrolyte. So electrolyte means the ionic solution. Electrolyte means ionic solution. If any solution contains ions, it is called electrolyte. We use electrolyte in batteries. All the batteries have electrolyte, okay? Battery is simple. If you want to, battery is this one. One is cathode, other is anode, third is electrolyte. Fourth is just the separator, which separate the, and this is the battery, okay? So now you understand electrolyte? Is this electrolyte solution? Is this electrolyte solution? Yes. Or not? Because this is metal, non-metal, means ionic compound. Ionic compound can dissolve, they convert into ions. So this solution is electrolyte. And this one, sugar and water. Is it electrolyte? Why?
No ion.
It doesn't produce ions. So sugar is not produce electrolyte solution. Okay. So now you understand electrolyte, non-electrolyte solution. Okay. So third part is very important. On micro scale, nano scale, molecular level, now you will understand why some liquid, solid and liquid dissolve from the solution. Why some doesn't dissolve. Reason is intermolecular forces. Okay. So this is very important to understand why solution form, why not. What happening inside. Okay. So students, this is the solvent, solute, and this is a solution. So intermolecular forces decide the solubility. Okay.
When two substances mix, the forces between the constituent molecules, or intermolecular forces, are disrupted. Intermolecular forces can be of different types, such as dispersion forces between nitrogen molecules, dipole-dipole attractions between hydrochloric acid molecules, hydrogen bonding between ammonia molecules, and ion dipole interactions between potassium ions and water. For a solute to dissolve in a solvent, solute-solute interactions between solute particles must be disrupted.
Now, this is the first step. If you are dissolving two components, first you have to break their intermolecular forces. In this process, is energy required provide or energy release? Provide, because in order to break the intermolecular forces, you have to provide the energy. Okay, so this is endothermic process. This is an endothermic process. Positive. Okay, so it means you have to provide some energy in this process to disrupt the solvent molecules. Okay.
So that solute particles are distributed evenly through the solvent. Solvent-solvent interactions between solvent particles must be disrupted to accommodate the solute particles.
For example, oil, water is very polar. Oil molecule doesn't dissolve in water. Or maybe, for example, okay, I will give you the one example. Calcium carbonate. It doesn't dissolve in water. Okay, although it is an ionic compound. Although it is an ionic compound, but doesn't dissolve in water. Why? Water is okay, separated, disturbed, but this ionic compound its ions are so strongly attached with each other, they are not disturbed. So we provide the energy to break this interaction, then its solubility increase. So this is the second part. So second part is this is 1, this is 2. So this is the disruption between solute particles. Solute particles also have intermolecular forces. If we break them, then they dissolve. Otherwise, they will not dissolve. They remain like a one particle. Okay. So it is also endothermic process. It is also endothermic process. If you successfully do these two processes, then they will mix each other. Okay. Otherwise, they will never mix.
Between solvent molecules. Solvent-solute interactions between solvent and solute particles must.
This is called solvation. Solvation means solute-solvent interaction start. Okay. No, they are disturbed and then mix. Then new interactions are created between solute and solvent molecules.
Be established so that the substances can mix.
So what do you think? Is this endothermic process or exo? Here, a new interactions are previously to break. Here, form. Here, intermolecular forces are formed. So what do you think? Is this process endothermic or exothermic? Is it endo or exo? Exo. Because when... So can you hear the sound? For example, if I drop this one, you hear the sound. Because earth and this are attracting each other. When they come to the earth, due to attraction, come close, energy is released in the form of sound. Similarly, when particles attract each other, they come close, they release their energy. Okay? exothermic process. So how many heats involved in solution formation? Watch out. How many energies and enthalpies involved in solution formation? How many? Maybe I discussed previously delta H1, delta H2, and this one is how many? Three. Which are endothermic? Which are exothermic? Do you understand endo and exo?
No.
Okay. No problem. Endo means enter, okay? Any process in which you provide energy, heat is going inside, enter, okay? Similar, it is called endothermic reaction. And exothermic process, okay, if I burn this one, heat will be produced and released to the surrounding, okay? So this burning process is exothermic, heat is going surrounding. And endothermic means heat is going from surrounding to in the system, okay? For example, if you are heating with the burner, heat is in the surrounding going in the system. So this process is endo or exo? Endo. Okay? Students, melting of ice. Last chapter we discussed. If ice melt, is it endothermic process or exothermic? It get the heat from the surrounding, okay? So it is so similarly here. Okay. So students, question is, in solution formation, two processes are endo, one process is exo. What is the net process? Net is endo or exo? In other words, you are doing two jobs, okay? So you get the money from one company and second company, okay? And you also spend the money in everyday life, you buy many things, so you use the money, okay? Spend the money. So what is your net money? Net money is increasing or decreasing? Or remain same? Simple answer. It depends on their total amount. Okay. If this is more, every month you earn more, consume less. What is the net? Net money?
Positive minus negative.
Again, students, again. If you are working in two companies, you are getting the money. Add means money is add up in your pocket, okay? From this company and this company. Means in this process, heat is absorb, okay? In this process, heat is released. Release means just like you spend the money. So what is the net effect on your total money? Total money is increasing or decreasing?
Depends on the bond.
Okay, I will give you one scenario. If your salary is more, your expenses are less. So every month your salary, net money, net worth, increase or decrease? Increase. It means net result is positive or net result is negative. Positive means more money come or more money go. It means similarly, if these processes are more, so net process is endothermic. You have to be give the energy, okay? But if this step you spend more money and earn less money, what will happen? If you spend more money and earning is less, what is the net worth? Your net money is going to be decreased. So similarly, if this is more, then this one, net result is also exothermic. It means you net result is exothermic. Okay, understand? Okay, what is the net result? Answer me. If this is a 3, this is a 1, and this is -7. What is the net result? Answer is
-3.
so this net heat is endo or exo? Exo. If this is this one, this is this one, and this is 7. What is the net enthalpy, net heat? Plus 6, plus 5, minus 7. What is the net answer? Positive or negative? Is this endo or exo? It means solution formation, sometime endo, sometime exo. It depends upon these two factors. If this is more, endothermic process. If this is more, exothermic process. Simple. Okay.
The extent to which a solute can dissolve in a solvent depends on how strong these three types of interactions are compared to each other. If the solvent-solute interactions are strong enough to overcome the solute-solute and solvent-solvent interactions, then the solute will readily dissolve in the.
This is the ultimate condition. If this is more than that one, then the solution form, otherwise solution will never form. Okay. So remember this. If solute-solvent interactions are more than this one, then solution will form. Otherwise, no.
Solvent. Consider a salt solution. Before mixing, sodium and chloride ions in the salt are held together in a crystal by ionic bonding. For water, the molecules interact with each other through hydrogen bonds. When sodium chloride is added to water, the water molecules arrange themselves in such a way that the positive end of the dipole faces the negative chloride ions, and the negative end of the dipole faces the positively charged sodium ions. These ion-dipole attractions weaken the ionic bonds between the sodium and chloride ions, so that the ions separate and the crystal structure breaks down. The separated ions are encircled by water molecules. Such interactions are collectively called hydration.
Yeah, this is a hydration. If water molecule surround the solute molecules, this is called hydration. Okay. Sometimes you say, "Oh, I am dehydrated." You drink the water, you see, I am hydrated. Similarly, this ion, when dissolved in water, water molecule attracted, so then it is called hydrated, hydration process.
The hydrated ions also overcome some of the hydrogen bonding between the water molecules. Now the salt is said to be dissolved in water.
So what is the condition for the solubility? Solute-solvent interaction should be solute-solute interaction should be more or less than the solute-solute solvent-solvent interaction. This is the criteria. Students, how many enthalpies, energies involved in solution formation? 3. One is to break the intermolecular force in solvent. Second, in the solute. Third, new interaction between solute and solvent. This is exothermic. This is endo. This is endo. Which of these is not intermolecular forces? Which is not intermolecular forces? This is a intramolecular. This is a like a chemical bond. Okay, this is not a intermolecular force. So, which force exists in solvent-solvent interaction? Which type of solvent-solvent interactions are disrupted when salts dissolve in water? When you dissolve salt in water, which interactions are disturbed? Hydrogen bonding, covalent bond, Coulombic, or banana bond?
What is banana bond?
Actually, in chemistry, this is also one type of bonds. So,
It is out of the scope. You say the real banana.
actually, sometimes, bond, for example, cyclic compounds. So their p orbitals and its p orbital is in this direction. Okay, so they cannot overlap. So they are just overlapping like this way. So they overlap in this way, okay? Their p orbitals are bent and they look like a banana, okay? Overlapping. So that is a banana shape. In cyclic compound, overlapping is not a parallel perfectly, okay? Hydrogen bonding. Actually, in water, solvent interaction is this one. Sorry. So this one is disturbed. Okay. Let's learn know the enthalpy. Enthalpy means heat. Are you ready? No, it is easy. Before previous video, I explained everything. Now you can easily understand some.
Dissolving the solute in a solution is either an exothermic or an endothermic process. When sodium hydroxide dissolves in water, heat is transferred from the solution to the surrounding water, causing the temperature of the water to increase.
So if heat is go from system to surrounding, it is called endo or exo. Exo just like exit, okay? Shuko, okay? Exit. And if heat go from surrounding to system, it is truco. Entrance, enter. Enter means endothermic, okay? Remember, endo, enter. Exo, exit.
This is an exothermic process. In endothermic processes, such as dissolving ammonium chloride in water, heat is absorbed by the solution, causing the temperature of the water to decrease. At constant pressure, the heat released or absorbed is called the enthalpy change.
This is the definition. Enthalpy change. The heat released at constant pressure. Actually, enthalpy is written by this one. Its actual name is enthalpy change, okay? It is actually nothing but heat. But the condition is pressure should be constant. Pressure should be constant. Like if I do any reaction here, does the pressure change of the air? If I burn this marker, does the pressure of the air change here? No, it remains one. It means if the pressure remains same, then this heat is called enthalpy. If this is a burning, then it is called enthalpy of combustion. Okay. If somebody is from solution, then it is called enthalpy of solution. If some reaction is neutralization, then it's called enthalpy of neutralization. If some material is going evaporate, it is called enthalpy of vaporization. So it has many names.
Solution formation has 3 steps, each associated with a corresponding enthalpy change. Step 1 is the separation of the solute particles. This requires an input of energy to overcome the attractive forces between the solute particles. Step 2 is the separation of the solvent particles. This is also an endothermic step. Energy is required to disrupt the attractive forces between the solvent particles.
What does mean by delta H solvent greater than 0? It means it is endo or exo. Greater than 0 means positive. It means it is endothermic. Ruko.
Step 3 occurs when the solute and solvent particles mix. This step is exothermic because the attractive interactions between solute particles and solvent particles release energy. For a stepwise process, Hess's law states that the net enthalpy change is the sum of the enthalpy changes in each step. The sign of the net enthalpy depends on the magnitudes of the enthalpies of the components. If the sum of the component enthalpies is less than the enthalpy of mixing,
Answer me. If the first 2 steps where you are disrupt the solute and solvent particles, if this net value is less than this of the mixed, the net enthalpy of solution is positive or negative? Negative. Okay, and this solution formation is endothermic or exothermic? Exothermic. First, good.
the change is negative. The solution process is exothermic. If the sum of the component enthalpies is greater than the enthalpy of mixing, the enthalpy change is positive, and the dissolution process is endothermic.
Endothermic means if you heat, you give the energy, then solution form. Okay? Endothermic means if you heat up, you give the energy, then this process is happening and then solution is formed. Okay?
If the two are equal, heat is neither released nor absorbed.
Yeah, this is a special case. This is not possible. This is not the possible. If this happen, that solution is called ideal solution.
Solution formation is different from a chemical reaction. When a solute is dissolved in a solvent, the change is physical. Upon evaporating the solution, the solute can be recovered. On the contrary, a chemical reaction alters the properties of the reactants. When copper hydroxide is dissolved in hydrochloric acid, evaporating the solution will not return copper hydroxide. Instead, we will obtain the product copper chloride. So it means solution can be separated into solute and solvent. Possible? Not possible. So it is a physical interactions. It is a reversible. Okay. What happened in the exothermic dissolution? If you dissolve something and process it exothermic, what does it mean? Heat is released or solution press release. What is the net outcome? Exothermic dissolution means heat is released when the solution is formed. All three enthalpies combined. Okay, so what is the enthalpy? What is the enthalpy? Enthalpy change, okay, it is entropy change or heat change at constant volume, heat change at constant pressure. So it is heat change at constant pressure. The definition delta H is equal to QP. So to understand what is QP? What is the QP? What is the QP? Q is heat, P means constant pressure, okay? Q means heat, P means pressure, constant pressure. If any heat absorbed or released at this constant pressure, that heat is called enthalpy of this person. Okay.
Still in the constant volume can be called that.
No, then it is not called enthalpy. Okay. For example, if you are heating any chemical in a closed container means pressure not remaining constant. Okay. More heat, more vapors, more pressure. Then it is not enthalpy. Then it is called heat. Actually, you have one chapter, thermodynamics. There I will explain you this one. Okay. Students, do you know the ideal solution? I have in one slide, I write the ideal. Ideal is, do you know the ideal person? Ideal person means which is very speak the truth, never lie, never cheat, honest. Okay. Is there any ideal person in this universe? Because we sometimes not behave like the ideal. Okay. Maybe one person is good than the other, but not similar students. Interesting thing is ideal solution. But there is no perfect ideal solution. But ideal solution is this one. Students, if what is this mean? It means delta H1 plus delta H2 should equal to delta H3. 3 means a mixture. 2 means solute. 1 means solvent. It means if your income is same and expenses are same, what is the net result? Your wealth increase or decrease or remain same. So this is the ideal case. Similarly, if there is no heat change during solution formation, it means same amount is used in endothermic process, same is release.
This is not possible. All solutions are either endothermic or exothermic. But if this happens, then it is called ideal solution. Okay. Second, if you are breaking the same type of forces and from the same type of forces, does volume change? I give you one example.
Okay, my question is if I add 50 ml water and I add here 50 ml ethanol, what is the net volume?
100.
One should be 100, okay? But actually it is not 100. It is less than 1. Why?
Because when these two particles, their volume is this one, they are not add up. When they combine, more internal forces, they shrink. They occupy less volume due to strong internal forces, okay?
So when you mix two liquid, their net volume is not add up, sum up. If they have less interaction,
If ethanol and water have less interaction, then their volume is more than 100, okay?
but if the volume change is 0, it means that solution is ideal.
The same forces here, when you mix same forces here, so it means volume doesn't decrease or not increase, okay? So see, this is the criteria for ideal solution.
And what is the definition of non-ideal solution? Non-ideal solution means if there is delta H is not 0 and delta V is not 0, okay? Then it is called non-ideal solution. So all the solutions are non-ideal, okay?
So what is no change in
For example, if you, for example, this is just like one solvent molecules. They have intermolecular forces. They need 10 joule energy to break. Okay. This is solute particles. For example, they need to be break 10 joule of energy to break them. Okay. Understand? When we mix and here solute and solvent interactions, how much energy required to break them? If it is still 10 joule energy to break them, it means they have a similar intermolecular forces, okay? Before and after. So then no volume change, no heat change. Same amount is utilized here, same amount is produced here. But if solute solvent interactions are more or less than the previous, then volume expand or contract. Heat absorb or release, okay? So that's why the non-ideal behavior may be positive deviation, negative deviation, okay? So good positive deviation, negative deviation. Okay. Students, next time we will learn a very, very useful topic for the chemistry students, bio students. We make a solution and there are a lot of units of the solutions. We will learn how to prepare them. Okay.
Yeah. Any question?
Because I want to know if the solid cannot in the gas
Yeah,
or in the gas to make solution.
because
So it can be a solution.
actually, for example, if you dissolve dry ice, if you put a dry ice in air, it is solid. But when it mixes in the air, it's sublime and mixed with the air. Then we can say it's solid in air. But if you say the smoke, example, this one, a smoke, dust particle is solid. When it go into the air, still it is a solid. So air and solid are two different phase. It is not one phase. It is not a solution. So smoke and dust is not a solution.
Okay.
Understand?
Okay.
But because here example is wrong, okay? But if you put a solid, for example, CO2, dry ice, and put in the air, it mixes with the air, then it is called solid in gas.
However, CO2 is truly become the gas.
Yeah, because the final form of the solution is decided by the solvent form. Solvent is gas, solution is also gas. For example, you dissolve the sugar in water. Sugar is solid, but after formation of solution, sugar is liquid form. Similarly, CO2, if it is solid, it dissolve in here, and then it become gaseous form of the solution. Okay.
Oh, so CO2 dissolves in the gases.
Gas.
Is the solid in the
In gas. Yes.
solution.
Yes. Excuse. Maybe sorry. Maybe if you, for example, this is a metal. For example, metal. Okay. If you heat this